Okay, A3. So this is our third video. We have learned the constant rule for derivatives. So we know that one. We have also learned the power rule. And we talked about the constant multiple rule, the sum rule, and the difference rule. Okay, so we're good with those two main, well, there's 5 rules, but these are the 2 main guys. And I'm going to extend them to be used for radicals too. So, because in grade 11, we learned that radicals could actually be written as exponents. So check this out. So instead of writing f of x equals root x, we could actually write that as x to the power of 1/2, right? We learned that in grade 11. And if you have y equals the cubed root of x, you can actually write that as x to the power of 1/3. So you could use the power rule to find the derivative of radical functions. So let's try it. So if we wanted to find the derivative of root x, we switch it so that it's actually an exponent. And then to find the derivative of it, we just use the power rule. So bring the 1/2 out front, x, and then we subtract 1. So it'd be like 1/2 minus 1. Instead of a 1, I'm going to make it a 2/2, just so the denominators are the same. And then I know 1/2 minus 1, or 1/2 minus 2/2 is going to be -1/2. And who likes negative exponents? Nobody. So I'm going to actually take that x to the power of -1/2, and I'm going to throw it in the denominator. So I'm going to keep this in my numerator, 1, and then 2 is in my denominator, and I'm actually going to bring that x into my denominator with the exponent of 1/2. Oops, sorry. And what else you could do, you don't have to do this step, but you could write it as 2 root x, because you know x to the power of 1/2 is just square root of x. So there you go. That's how you find the derivative of a radical function. Okay, let's try the next one. So if we have y equals x to the power of 1/3, we want to find the derivative, so dy by dx. So we'll bring the 1/3 out front, keep the x, and then it's going to be 1/3 minus 1. But let's make the 1 a 3/3, just so they have the same denominator. And let's subtract them. So we get -2/3. And again, nobody likes a negative exponent. So let's put our, let's put this guy into the denominator. So it becomes 1/3 x to the power of 2/3. And again, if you want to, not a requirement, you could switch that. Since it's got a 3 in the bottom of that fraction, we know it's a cube root. And the 2 that's right there, we know that's actually the exponent. So you could write it that way. It's up to you. Okay, so that's how you would use the power rule to figure out the derivative of radicals. All right, so let's look at polynomials. So we don't really have, we haven't learned, there's a rule called the product rule, and that rule is helpful for when you have 2 things multiplied by each other. But since we haven't learned that rule yet, there is a way you can solve these things, and that is to first expand them. So first expand these brackets. So it would give us 2x squared plus 2x minus 3x minus 3, which would be 2x squared minus x minus 3. Okay, and then, now that we've simplified it, now we can just use our power rule and our constant multiple rule to find out the derivative is going to be, so the derivative of this one is going to be 4x. The derivative of -x is going to be -1. And the derivative of -3 is going to be 0. So our derivative will just be 4x minus 1. Okay, for g of x over here, now we have a fraction, which there is a rule for that too, called the quotient rule, but we have not learned that. So what we could do is we could split these up into separate fractions, and since the numbers are amazing, then we can actually get rid of our fractions. So we can split this into negative 8 x to the power of 6 over 4 x to the power of 5 plus 8x squared over 4x to the power of 5. So we can split it up into two separate fractions and just simplify those fractions. So negative 8 divided by 4 would be negative 2. And then x to the 6 divided by x to the 5 would just be x plus 8 divided by 4 would be 2. And then x to the power of negative 3. And then if we wanted to take the derivative of g of x, we just do this one first. So the derivative of negative 2x would be negative 2. And then we would take the derivative of this one. So 2 times negative 3 would be negative 6x to the power of negative 4. And then if I wanted to, I could write the x to the negative 4. I could write x to the 4 in the denominator just so that I don't have a negative exponent. And there you go, derivatives of polynomials. Okay, let's talk tangent lines. So we can determine the equation of a tangent line at x equals negative 1. Okay, so what do we need to determine equations of lines? We need slope and we need y-intercept because our equations are always y equals mx plus b, so we need to know those two things. Okay, so I know we can find the slope because we can get the derivative and sub in negative 1. So let's do it. So if we wanted to find our slope, we just find the derivative of f of x. So I'm going to use all my rules. So first, 4x cubed is going to become 4 times 3, so 12, x to the power of 2. Then the next one's going to become 6x, and then the minus 5 is just going to be 0. Okay, so that's the derivative, and then I sub in negative 1 for x, and that will find me the slope at negative 1. So I got a negative 1 squared would just be 1, so that'd be 12 minus 6. So our slope is going to be 6. Okay, so that is the slope. And to find the y-intercept, I probably need a point on my line. So since I'm trying to find the slope or the equation of the line at x equals negative 1, let's find the y value there. So let's just take our equation and sub in negative 1 into our original f of x, just so we can figure out the actual xy coordinate. Okay, so negative 1 cubed is going to be negative 1, so that's going to be negative 4 plus 3 minus 5, which is going to be negative 6, I think. Yep. So that means we have our point on our function is at negative 1, negative 6. Okay, so we don't have a y-intercept yet, but we can use our equation, y equals mx plus b. We can sub in our slope, which is 6. And we can actually sub in our point, so negative 6, negative 1. And that can help us find our y-intercept. So negative 6 equals negative 6 plus b. So negative 6 plus 6 equals b. So our y-intercept is 0. So now it looks like the equation of our tangent line is y equals 6x plus 0. So it's just y equals 6x. Cool, so basically all we did was we took this function and at x equals 1, we found out I don't know what, I'm sorry, this is probably a totally inaccurate graph, but we found out at negative 1, at negative 1, negative 6, we know the slope of our tangent line is 6, so we're just finding the actual equation of that tangent line. And that's how you do that. Okay, that is it.